To introduce you to in-system programming in AVR Studio 6, we'll use an example project for the SAM3N EK called Getting Started SAM3N EK. This simple example makes two LEDs on the board blink at a fixed rate. We have opened the example project and are going to program our SAM3N EK board with it. Now remember to connect your programmer and board to the computer. Here's the main file. Let's right-click the project name in the Solution Explorer to open the Project Properties dialog. The default output of an Atmel Studio build is a .elf file. You can see that this is the output file format here. While we have the Project Properties dialog open, we can select the SAMICE as our debugging tool on the Tool tab. This will connect to the SAM3 via a jtag interface. Clicking on the Device tab, you can check that the selected target device is the AT-SAM3N4C. Now we're ready to build the project, selecting Build Solution from the Build menu or pressing F7. Our project is now built, and the .elf file we'll use to program our target is generated. The output at the bottom of the screen says Build Succeeded. To program the compiled program to the device on our board, either click on the Device Programming button or go to the Tools menu and select Device Programming. In this example, we're using the SAMICE Programmer and Debugger, but the process is the same for any of the Atmel tools, for example, the jtag 3. Now, check that the correct device is selected in the Device drop-down list. The device selected is the AT-SAM3N4C, which is the device that was selected in the Device tab of Project Properties. The correct programming interface is selected, in this case, JTAG. OK. As we click Apply, the Seger J-Link control panel window pops up. This will only happen when using the SAMICE to program ARM processors, but the rest of the programming procedures will be the same for AVR, Xmega, and UC3. In this case, we can just minimize this window. Next, to verify that we have a working connection between the programmer and the target device, we will read the device signature. It is a good habit to always check this before trying to program your part. The status message says, Reading Device ID OK. This means that we have a working connection. You should also try reading the target voltage. The device needs to be sufficiently powered to be programmed, and if this test fails, check your connection and the power to the device and try again. OK. Now click on the Memories tab of this window. This is where you select what to program into the target device's flash memory. For some microcontrollers, you can program specific contents for the EEPROM here as well. Let's first click Erase Now to erase the device. We can also include that as part of the programming process by checking Erase Flash before programming. Next, navigate to the location of the file you would like to program onto the chip. In Project Settings under Build Configuration, we chose the Debug configuration. So when building, the output was created in the Debug subfolder in our Project folder. Two file format options will be available: Getting Started 1.elf as well as Getting Started 1.hex. Select the .hex file and click Open. Let's leave the Verify Flash After Programming option checked. When we now click Program, the device will first be erased, then programmed, and finally, the flash memory of the target device will be read back and compared to the .hex file to verify that the programming was successful. You can see this if you watch the status window at the bottom of the dialog. Click Program to program the chip. OK, the chip's flash memory is now programmed. The SAM parts have a tab called GPNVM bits, or General Purpose Non-Volatile Memory bits. These are the equivalent of the fuses on the AVR devices. Click on this tab. As you do this, all the GPNVM bits, or fuse settings for an AVR, on the device are being read back and displayed in this window. You can see the short names for the GPNVM bits, and by hovering the mouse cursor over them you will get the full name. Let's unselect the boot mode selection. Setting the GPNVM bit 1 selects the boot from the flash. Clearing it selects the boot from the ROM. Notice that as we unselect boot mode selection, the status icon to the left changed from a green checkbox to a yellow exclamation mark. This means that the selected option differs from the actual GPNVM settings on the device. To write the GPNVM changes to the device, press the Program button. Now we have cleared the boot mode selection NVM bit, and the SAM3N will attempt to boot from ROM. And as you can see, the GPNVM memory selection in the device is now the same as in this dialog. We'll change it back again since we actually want to boot from the flash. Next, if you want to change the security bit of the device, lock bits on the AVR microcontrollers, go to the Security tab. Here we have the option of setting the security bit. If you have set the security bit, you must erase the chip before you will be able to debug again. This must be done by connecting the jumper on the SAM3N EK, which pulls the erase pin high, erasing the flash. For demonstration purposes, we'll set the security bit. When we now attempt to read the device ID, we get the error message, "Unable to enter programming mode. Verify interface settings, target power, and connections to target device." For more information on GPNVM bits, fuses and lock bits and what they do, consult the relevant datasheet. Now we've erased the device using the jumper, and we open the device programming dialog again. If you click on the Device Information tab, you'll find a link to the datasheet. For more help on the device programming window, click on the question mark on the top right to open the Programming Dialog section in the Atmel Studio 6 help files.